All right, so let's take a look at if we have two transcendental functions, e to the x times sine of x. Now for this one, since they're both transcendental, it doesn't matter which one you're going to let be u and which one you're going to let be dv. But you do have to use integration by parts on this one. Remember, that's going to be uv minus the antiderivative v du. So it doesn't matter which one. So I'm going to let u be my x, because u is there, my x. Let dv then be the sine of x dx. When you integrate u, we're just going to get e to the x dx. And the antiderivative of sine of x, be very careful, is negative cosine of x. So I'm going to write this out, uv, so u times v. So this becomes negative cosine of x times e to the x minus the antiderivative of v du. Now the negative, I'm going to factor that out, and that's going to give me e to the x times cosine of x dx. Now we do have a problem here, as you can rightly see, is we have to use integration by parts again. This is a very lengthy process. So we're going to get u again is e to the x, and I'm going to let my dv now be cosine of x. Don't forget the dx. Taking the derivative of u, again we get e to the x dx, and the antiderivative cosine is just sine. Sine's derivative is cosine, so if we integrate cosine, we get sine of x. Using our one rule again, we're going to get this negative cosine of x, e to the x, plus, and I'll put this in brackets, uv, so e to the x sine of x minus the antiderivative of v du. So that becomes, again, e to the x sine of x dx. Now, most people think, oh no, look at this, we got to do it again. But not really, because if you notice, this integral, again, is the same as my original. So I know that this is equal to the antiderivative of e to the x sine of x dx. I know that those two are equal to each other. And I can use algebra to solve for my integral. So this becomes negative cosine of x, e to the x, plus e to the x sine of x. Now, and I'm going to bring this over by adding it, and that becomes 2 times the integral of e to the x sine of x dx. So how do I solve for the integral then? Well, therefore my integral e to the x sine of x dx is just equal to half of this. 1/2 of, I'm going to write this as negative e to the x sine x plus e to the x, whoop, that should be e to the x cosine of x, there we go, plus e to the x sine of x. Now normally we would put a plus c1, but they do want us to evaluate from 0 to 1 here. And there's our antiderivative, that should be cosine of x, there we go. And now if we do our fundamental theorem, we would get 1/2, plug in the 1, negative e cosine of 1 plus e sine of 1 minus, plug in the 0, e to the 0 is 1, so that becomes negative 1, cosine of 0 is 1, plus e to the 0, which is 1, times sine of 0, which is 0. And I can simplify this as 1/2 times, this is just negative e cosine of 1 plus e sine of 1, and that becomes plus 1. And there's our answer. Slow that down if you need to, okay? Alright, our next example, let's see here. Let's take a look at another tricky arc trig one, okay? Because we're going to see this one in our test and our quiz and everything. So I want to make sure we get this next one down here. Number 11 here. (2x minus 5 over x squared plus 2x plus 2 dx). Now this is a tricky, this is not a u substitution, because again, we try to u, our du would be 2x plus 2 dx. But this is the one that was really close to a u substitution. If that minus 5 were a plus 2, I could do u substitution. So this is the one where we're going to use u substitution, but we're going to have to make this a 2x plus 2 on top. And you might remember how to do that. We're going to add 7 to both on the top. So if I go 2x minus 5 plus 7, but to fix that we had to subtract 7. over this x squared plus 2x plus 2 dx. This is what I wanted, because that becomes 2x plus 2 over this x squared plus 2x plus 2 dx. But now I have that extra 7, so I minus that new integral, minus 7, and 1 over x squared plus 2x plus 2 dx. You're going to see this one again, so every day you're going to be seeing these are practices. So for the first one, this is our u sub. We know that we created it. We made it so it can cancel out at the bottom. This one, this is going to be my arctangent. Remember arctangent, 1 over a, arctangent u over a. We will have to complete the square here. But let's do it with the u substitution. My u is, of course, x squared plus 2x plus 2. Our du is 2x plus 2 dx. And so we get dx is, of course, du over 2x plus 2, and those cancel. So this is not that hard to actually answer right now. Remember, this is just all u right now. 1 over u, we get the natural log of x squared plus 2x plus 2 minus 7, and now we're going to integrate this one. Remember we said we have to complete the square here. X squared plus 2x plus a blank plus 2. I have to add 1 here, so to fix that we subtract 1. So arctangent, remember this is arctangent is a squared plus u squared. So I'm going to switch that order around. That becomes, my new integral becomes 1 over 1 plus x plus 1 squared dx. So my a is 1, my u is x plus 1, so my du is just dx. Always check to make sure nothing I don't divide by anything. And then I can write my answer. Arctangent, 1 over a, so it's 1 over 1. Arctangent u, which is x plus 1 over 1 plus c1. And there's our antiderivative right there. All right. The last one I want to kind of start with us, let's see if we have time here, is number 13. And we might have enough time for this one, so if we take a look here at number 13, we have this x cubed over x squared plus 4 dx. Now again, this looks like it might be arctangent if that was a 1. However, it's not arctangent because I don't have a 1 on top or anything like that, a constant. This is actually the one where we have to divide. So again, just like the first example we did in the first video, we have to divide. We take this x cubed and we're going to divide it by this x squared plus 4. This is that big on top, the BOT. We want to divide these. X gets multiplied by x here. That's going to give us x cubed plus 4x. And when we subtract, well, let's see what we're left with. When we subtract this, these cancel. We're left with minus 4x. So my new integral will be x minus, I'm going to put this 4x over x squared plus 4 dx. And this I can integrate. Ready? Well, that is just x squared over 2 minus, but over here we have a u substitution. So let's see if we can do this real fast. I know it's going to be u substitution because the derivative of x squared plus 4 is 2x. The x's should cancel. So that's going to become x squared plus 4 du is 2x dx. Give me dx is du over 2x. And again, those x's will cancel. So what are we left with? Remember, this is 4 over u. So we got this 4. We're going to divide that by 2. But remember, that becomes 1 over u. And the antiderivative of 1 over u is natural log of u. So we get the natural log of x squared plus 4 plus your constant of integration. And there's our antiderivative. So definitely check a look at these. Try these out. And have fun. Like and subscribe. Smash that like button. Bye.